Hello everyone. In this video, we will be dividing rational expression, and this is the second part. I will put the link of the first part in the description box below. Before we determine the quotient of these two rational expressions over here, let's have a review on the basics of dividing rational expressions. Please remember that in dividing rational expression, it's pretty much just like dividing fraction. What we do is we flip the divisor and multiply across. So in this case right here, if we have fraction or rational expression a over b divided by c over d, then the c over d fraction is our divisor, and we are supposed to flip this around so that d becomes the numerator and then the c becomes the denominator. So pretty much our a over b stays the same, but then our c over d has been flipped around, so it becomes d over c. And then after that, we're supposed to multiply them across. So that's how we got a times d over b times c. And this is true when b is not equal to 0 or c is not equal to 0, or both of them should not be equal to 0, because if they are equal to 0, then this expression becomes undefined. Okay, going back to the example that we have here, in order that we can determine the quotient for this, we need to follow some steps. The first step is to factor out both the numerator and the denominator. So I'm just going to show the work on the side here where we are going to factor all the numerators and all of the denominators. So I will divide this into 4 since there are 2 numerators and there are 2 denominators. So we're going to start with this one right here. So that is 8x cubed minus 4x squared. And then this spot right here would be for 4x squared plus 12x. And then this spot right here would be for 4x squared minus 1. And then this one right here would be for 2x squared plus 5x plus 2. Since there is a common factor to both of these, which is 4 and x squared, so we're going to factor out the GCF. So in this expression right here, so I'm just going to show the work on the side here. Okay, so in this example right here, or in this part, we will have a combination of both factoring out the GCF and using the box and diamond. So in this two other expressions that we have here, there are no common factors, so we cannot factor out the GCF, but instead we can use the box and diamond for this. So anytime you can't factor out using the GCF method, you can go ahead and use the box and diamond. So in this case right here, we can actually rewrite this as 4x squared plus 0x minus 1. So pretty much that is that's a trinomial right there. So we can go ahead and factor this out using the box and diamond. So that would be 4x squared, that's a negative because you have to multiply the first and the last, and then that's a 0x at the bottom. So the factors here would be positive 2x and negative 2x. So using the box or the area model for this, we're gonna to determine the factors. So that would be first term 4x squared, the last term negative 1, and then you can put the 2x and the negative 2x anywhere on these two boxes right here. So then the factors here would be 2x and then 2x, and then we have a negative 1 and then positive 1. So then the factors are 2x plus 1 and 2x minus 1. So I'm just going to go ahead and write that up here. So 2x plus 1 and 2x minus 1. And then I will do the same thing here. I'm going to use the box and diamond to factor these out. Okay, so I factored it out and then we got this expression already factored out. Now the second step is to flip the divisor, multiply across, and simplify. So we're gonna flip this second fraction right here. So I'm just gonna go ahead and rewrite this. Okay, so I flipped it. So the numerator becomes the denominator becomes the numerator. So then we're going to simplify this by crossing out those that are like terms. So this one gets crossed out, 2x minus 1, and then 2x plus 1 and 2x plus 1, x plus 2 and x plus 3 cannot be crossed out. So we keep them. So the ones on top, the leftover would be 4x squared, and then we got a parentheses, x plus 2, and that is over 4x, and then we got x plus 3 at the bottom. So then we can go ahead and simplify this some more. So that would be 4 times x and x. So there are 2 x's, and then multiply the x plus 2, and then this would be 4 times x, and then multiply that by x plus 3. And so we can cross out the 4 and the x. So the leftover is just x and then these two. Now others are going to get tempted to cross out this x and x here, or this and this. We can't do that because this parentheses is telling us that they are together. We cannot break them apart. So then the final answer here would be, the top is x times x plus 2, and that is over x plus 3. So this is the quotient of this rational expression when divided together. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We pretty much have the same step. The first step is to factor out both the numerator and the denominator. So then I am going to show the work on the side over here. So I'm just going to divide this into 4 parts for all of the work that we're going to show. Okay, so we're ready to move on to the second step. The second step is to flip the divisor, multiply across, and simplify. So I'm going to flip this fraction right here. So I'm just going to go ahead and rewrite this. Okay, so then from here we can go ahead and cross out x minus 4 and x minus 4. We have x plus 3 and x plus 3. Then we have 2x minus 1 and 2x minus 1. So we are left on top with 5x over just x at the bottom. So then we can go ahead and cross out some more. This x and x gets crossed out. So the final answer for this is just 5. So the quotient when this two expressions are divided together is 5. So I'm just gonna put that answer up here. Now, did you get the same answer as this? 5? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!